Alright, so we're going to go ahead and create a console application. And this console application is going to be an example of a singleton. So as I'm typing, you'll see that I'm choosing console application, C# is the language, and the product name singleton for our purposes. So we're going to go ahead and create that. You'll see main class created with main, static void main, string args, and the default console.writeLine hello world. And we'll go ahead and get rid of that. Next, we're going to go ahead and we're going to add a new item, and that new item is going to be an empty class, and we're going to go ahead and call it State Manager. If I can spell. And the reason we're going to call it State Manager is usually you use a singleton to manage state between multiple threads. We do not want the constructor of the State Manager to be public because we do not want anyone to create an instance of this class. Instead, we're going to create a private static State Manager, which is going to exist only as one instance of that class, which is what it means to be static. So we're going to follow all the rules. Private variables start with an underscore, according to both ReSharper, JetBrains, and Microsoft way of doing things. We're not going to put anything in the State Manager because usually the constructor is empty. We're going to go ahead and we are going to create some shared data now. And it's going to be volatile, so all the writes will be seen. And it's going to be an int. My int, for the whole purposes of it, if I can spell my int correctly according to rules. And we're going to go ahead and create two methods now. Public void setInt, and then I equals, go ahead and set that int up. Every write is guaranteed to be seen, and it is by the read, but the reads are not necessarily to be seen by the writes, which means it's not guaranteed to be synchronous beyond FIFO ordering. We're going to go ahead and return that int, and that's what getInt does. And we're going to go ahead now, and we need to give people access to the State Manager, static State Manager. So we're going to go ahead and create an instance. This is how singletons are declared in .NET as an instance method. And it's only going to have get because it's only going to be read-only, so we'll have no assigning of it. And it's static because we only want one instance of this method because the State Manager underscore manager is indeed static. So right now it's going to cry because this is null, and so we need to instantiate it. So here's what we need to do. If it is null, right? So it as manager double equals null, then what we're going to do is we're going to go ahead and lock on some object. This is called two-phase locking, and we're going to need a lock. And so we're going to go, I'm going to go ahead and create a private object, lock equals a new object. And I'm going to go ahead and follow protocol and everything. I'm going to make it static, of course, because it's accessed in a static method, and instance parameters and instance variables are not accessible at that level. So here you go, and then I'm going to check again if it is null. Then I'm going to go ahead and instantiate it. So if manager double is equal to a new state manager. And that is our singleton in full. But I argue that since this code is loaded at byte time, all static variables are loaded at byte time, and the constructor doesn't take any arguments, that we can actually comment out the two-phase locking, which has some flaws within it from a thread point of view. And because this if statement is executed every time instance is called, we can get rid of it. So that's what we're going to do. And just let me comment this out. If I can. And I'm going to go ahead and I'm going to instantiate it at class time. So this statement's going to be run as soon as the bytecode is loaded. So therefore, it's guaranteed to be synchronous and therefore thread safe. So that will take care of everything to do with our state manager. We no longer need the lock, but I'll keep it around just to show you how things are. And let's let's go ahead and decide what we want to do with this. Let's go back to program, and what we're going to do is I'm going to show you a threading example so that you can see how threads talk to each other through a singleton. Now, the first thing we're going to do is instantiate a couple of threads. So we needed to import system.threading for that. And what we're going to do is go ahead and do new thread. Threads take a thread start, and they can be anything you want. So we're going to go ahead and create a static function for it to take, because it takes a function prototype, and run is it. And we're going to go ahead and spell it out. It's going to be a simple for loop iterating through, and we're going to go ahead and instantiate it with a new thread start, and we're going to pass in run as the function pointer right there. More method pointer there. And so we're going to go ahead and set the int in this one. And keep in mind these are two different threads. And we're going to go ahead and just iterate over a for loop, because that's what we'll do to set this. And you'll see that the communication is FIFO ordered, which is not necessarily synchronous in the terms of having everything line up particularly well, in terms of forcing it to be one then the other then the other then the other. And keep in mind, these two threads I'm going to create do not have any correlation to each other. So in that regard, basically they have no way of communicating other than through this state manager I'm talking with. This is the only shared data. There's no database. There's no, usually you would talk through a database if you were between processes, but threads will talk the way threads talk through usually state managers through, that's how sessions are run. When you're doing a BitTorrent client, you'll have a state manager that manages what's already been seen and what hasn't. and putting the bytes in the right order. Gonna go ahead and I think what I'm gonna do is create another function, and I'm gonna call it run2, and what this is gonna do is gonna print it out, because I don't want them to basically compete for the same resource and get and set, because I want you to see there's a complete difference between the two. So I'm going to get rid of the set there, and I'm going to get rid of the that was wrong. I'm going to go ahead and get rid of the console.writeLine from here, and I'm going to go ahead and build, and should build fine, should work. And I'm going to go ahead and start these threads, of course, before I forget. And yeah, build all. Let's keep our fingers crossed. Actually, we don't have to. One warning, whatever, no build errors, that's good. And we'll go ahead and start without debugging. And what you should see is a FIFO ordering. Let us see. Okay, so what actually ended up happening is that run ended up costing, it basically ran on the CPU first, and it didn't have time to switch to the other thread. So what I'm going to do is I'm going to add thread.sleep to run, and when I move it to run and add thread.sleep, what's going to end up happening is that you'll see that it does actually switch between the two. So hopefully, no. Yeah, I know it's not used, blah 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 blah. Sorry, I was just checking out the exception, not the exception, the thing why it was complaining. Well, of course it's not working. So we'll go ahead and set this for 1 second. Those time in milliseconds, and 1,000 milliseconds is a second. So let's go ahead and copy that and put that under, just to keep with consistency. And we should be able to build and run. Of course, always start without debugging. No, not with debugging, but start without debugging. And here we go. You can see that the two threads are talking to each other and using the state manager. Now, the reason they're completely synchronous and they see every single number is because of the sleep. But as you can see, the only way they're talking to each other is through that state manager. Thank you.